Hello, math humans. We're going to do 4.4 today. We're going to be talking about trig functions of any angle. Our objectives are that we're going to evaluate trig functions of any angle. So I want to go back and review each of our basic trig ratios. Remember that sine is y over r, cosine is x over r, tangent is y over x. Tangent is also sine over cosine. Remember your identities. Cosecant is r over y. It's the reciprocal of sine. Secant is the reciprocal of cosine. It's r over x. Cotangent is the reciprocal of tangent. It's x over y. So remember, in the unit circle, the radius is 1. Okay. My triangle that I do math on sits on the x-axis. I never do math up here. X, Y, and R. If this is a point, it is a point of intersection between the triangle and the unit circle. It has coordinates x, y, which means that it also has coordinates cosine of theta, sine of theta. Something that's hugely important, is this word exact. It basically means no calculator. It means to get something in a precise answer without decimal places. And in trig, that typically means we're going to use our special right triangles. So as we start, let's do example number 1. And it says, let the point -3, 4 be a point on the terminal side. And terminal side, remember, is where we stop our rotation of theta. Find the sine, cosine, and tangent of theta. Okay? The first thing that I'm going to do, which is almost always the first thing that I do in a trig application, is I'm going to locate my point. So this is -3, 4, so that means it's going to be a -3. This is 4. This is a Pythagorean triple, which means that the hypotenuse is 5, and that's lovely. So then the sine of theta is going to be 4 over 5. The cosine of theta is a -3 over 5, and the tangent of theta is 4 over 3. I typically move my negative to the top so that I don't lose it. I'm going to harp on the fact that you always want to put your SIGN signs, the negative, on your sketch for your reference triangle, because if you don't put it here, that means that it typically doesn't make it over here, and then you make mistakes on tests, and then it's a really sad day. For example number 2, we're going to be given that the tangent of theta is a -5 over 4, and the cosine of theta is positive. Greater than 0 means that it's positive, and I want to find the sine of theta and the secant of theta. Okay, so the first thing that I want to talk about is drawing our reference triangle. Okay, so if we think about tangent is y divided by x. Tangent is negative when only one of the two angles are negative. So tangent is negative in the second quadrant and the fourth quadrant. And then the second condition says that cosine is positive. Cosine's negative over here, so our triangle is down here. It's where they overlap. Okay, so then I'm going to add my information. It's y over x. X is positive, the y is negative, and then this is 4, this is 5. My hypotenuse is going to be the square root of 41. So it's the square root of 25 plus 16, okay, just the Pythagorean theorem. Alrighty, notice that I've drawn my triangle. Everything is well labeled. I have a positive, a negative, and I have my hypotenuse. The sine of theta is y over r, so it's going to be a -5 over radical 41. Remember, we do not rationalize. And the secant of theta is the reciprocal of cosine, so it's going to be r over x, and that's going to be my radius radical 41 over x, which is 4. So that means that it's very simple, okay? making the drawings is key to your solution to the problems. Alrighty. For example number 3, alrighty, it says evaluate, and we're going to add that lovely word exact, the cosine of 4 pi over 3. So the way that I would start this is I need to remember my angles. Pi over 3 is 60, so this is a 60 times 4, which is 240 degrees. That is faster than counting in pi over 3s. 240 is 180 plus 60, so that means this is 60. This is a negative radical 3. This is a negative 1, and this is 2. Alrighty. This is really important that you draw. It's actually going to be part of the points that you will receive on every problem, because if you get the problem wrong, oftentimes if you have your diagram, you've usually put it in the wrong place. So this is a required element of the problem. So then the cosine of 4 pi over 3 is going to be x over r, so it's a negative 1 over 2. And then I report the cosine of 4 pi over 3 is a negative 1/2. You can take the time to memorize the unit circle. I will tell you that I think it's a waste of time. All right, let's do our next example. Example number 4. I think it's a waste of time because I can regenerate every special angle and find my precise coordinates very quickly. So the next one says evaluate, and again I want the exact coordinate of the tangent of a negative 210 degree. Okay, so if we go ahead and go here, 210 is 180 plus 30. I'm going in the opposite rotation, so here's 180 plus 30 degrees more. So this is 1, this is a negative radical 3 and 2, okay? And then the tangent, negative 210 degrees, is y over x, so that's going to be 1 over a negative radical 3. Don't rationalize, and I typically move the negative to the top, and so then I would report the tangent of a negative 210 is a negative 1 over radical 3. All right, our next example, example number 5, we're going to have let theta be an angle. We love theta as an angle in quadrant 2. Okay, and that means that pi over 2 is less than theta is less than, that's theta, pi, such that the sine of theta is 1/3. And I want to find the cosine of theta and the tangent of theta. And again, we're going to do exact because you need to get used to looking for problems with this word exact. Exact means no calculator. You can use your calculator to find a missing side, like using the Pythagorean theorem, but when you report your angles, it should be reported as an exact measure. So sine is positive, and they told us that it's in the second quadrant, so that means that my little triangle is here. This is 1, this is 3, and if I use the Pythagorean theorem, I'm going to get that this is a negative square root of 8, which is a negative 2 radical 2, because remember, we always have to reduce our radicals. Okay, and the 8 came from doing the Pythagorean theorem. 9 minus 1 is 8, so that's the square root of 8. So then the cosine of theta is x over r, so it is a negative 2 radical 2 over the hypotenuse, which is 3. And then the tangent of theta is y over x, and tangent is going to be 1 over a negative radical 8. I would write it as a negative 1 over radical 8. And remember, we do not rationalize our values, okay? All right. Sorry, my bad. I need to write this as 2 radical 2. Whew, that's better. So another thing that's interesting, and let me just show you on this problem, is I could have gotten this answer a different way. I could have done the tangent of theta is the sine of theta over the cosine of theta, Well, the sine of theta was 1 over 3 over the cosine of theta was negative 2 radical 2 over 3. If you multiply it by the reciprocals, you get 1/3 times a negative 3 over 2 radical 2. The 3's cancel, and you get negative 1 over 2 radical 2. So I got the exact same answer. It's just another way of thinking about the problem. Okay. Example number 6 says find two solutions of the equation, and we're going to go from 0 to 2 pi because that is one full positive rotation, and we're going to be given that the cosine of theta is radical 2 over 2. Okay? All right. So as I start this problem, the first thing that I would do is unrationalize. I hate it when things are rationalized. Okay, so I'm going to write that the cosine of theta is 1 over radical 2. And cosine is positive, so when I draw my triangle, cosine is positive here and here. So then this is 1, this is radical 2. It's the same 1, and then this is radical 2. Well, if this is 1, that means this is 1, so this angle is pi over 4. And then I take the positive rotation. I don't take the negative rotation because this is a positive rotation only. And then this is going to be 7 pi over 4. Remember, I can count 1, 2, 3, 4, 5, 6, 7. So this is 7 pi over 4. Therefore, theta is equal to pi over 4 and 7 pi over 4. Okay? Alrighty, so those are my two solutions for theta. All right, I have one more example and then we are done for the day. So example number 7 says find two solutions. And again, I didn't mention this in the last problem, but the variable in the problem is theta, right? So that's why there are two solutions. That's why I reported my answer as theta equals, because theta is the variable. Find two solutions of the equation. The sine of theta is radical 2 over 2, okay? And we're going to do in one positive rotation from 0 to 2 pi. I'm going to draw my reference triangles. Sine is positive here and here. I would write this as sine of theta is 1 over radical 2 because I think the problems are significantly easier when they are unrationalized. So this is 1 radical 2, so this is pi over 4. And this is 1 radical 2. This is 1, 2, 3. This is 3 pi over 4. So theta is equal to pi over 4 and 3 pi over 4. So remember we talked about where sine and cosine are positive and negative. When you get, as we finish this lesson, in the first quadrant, this is positive, positive. Remember that the positive, positive technically is an ordered pair, is x, y, which is also cosine theta, sine theta. In the second quadrant, it is negative, positive. In the third quadrant, it's negative, negative. And in the fourth quadrant, it's positive, negative. So if we look at our diagram, cosine is positive in the first and the fourth. Sine is positive in the first and the second. Tangent is positive because tangent is y divided by x. In the first and the third, two negatives make a positive. Tangent is negative in the second and the fourth. Alrighty, that's it for today. I will see you soon.